Welcome everybody. I'm Julia Gerlach with No-Till Farmer, and I'd like to welcome you to today's No-Till Farmer webinar, Get the Most Out of Your Planter by Taking Care of Every Little Detail, brought to you by Precision Planting. We're fortunate to have with us today Hans Stutzman, and Hans has been working in product support at Precision Planting for about 10 years. Hans grew up on a farm in central Illinois that his family still operates today, and he remains active on the farm. And we also have Joel Rieker doing our camera work today at the facility with Hans. So thanks guys for joining us. For today's webinar, Hans is going to discuss practical planter setup and maintenance that will help your planter perform well and provide the best potential yield that it can. Before I turn things over to Hans, just a couple of housekeeping items that we want to make you aware of. We do have at the bottom of your Zoom panel, there is a Q&A icon, and we would love it if you would put any questions that you have throughout the webinar into that panel. And Hans is going to be addressing those questions as he goes. So if something comes up as he's walking through the planter and you think of a question, be sure to get it in there. Of course, we'll go back and double back and get to anything that you didn't get to later on. But, you know, if you think of something while he's on the openers or something like that, be sure to ask then. And then if for any reason the webinar is disrupted or you're seemingly disconnected from the broadcast, just go back to the invitation email that you received and rejoin the webinar through the web link in that email. With that said, thanks again for joining us, and I'm going to turn things over now to Hans Stutzman. Thanks for joining us.
Good morning. Thank you, Julia, for introducing us. First of all, I want to thank No-Till Farmer for letting us come on and for hosting us as do a planter maintenance to get in front of you customers and just to talk through a little bit about planters. As Julia said, my name's Hans. I'm excited to be here with you. We'll talk a lot about planter maintenance, just kind of what is it and why does it matter? What are some of the impacts that we have with it? So again, thank you, No-Till Farmer, for having us on, and thank you guys for attending with us today. So one of the first things I want to talk a little bit about is why planter maintenance? What are some of the things that we talk about with planter maintenance? And as I think through it, a lot of the things we're trying to do as we take that planter to the field, there's a lot of things we're trying to accomplish with one single pass of the implement, and we're trying to do it seamlessly. One, we want to get seed in the ground to the proper planting depth. We want to hit that 2-inch or 1.5 or 2.5, whatever it is that we have deemed the right depth for that year to hit that planting depth. We want to get in the ground to 2 inches, and then we also want to make sure that's in moisture, so that dictates what that depth is going to be. So we want to hit that 2-inch planting depth, the moisture line. We want to get the right density of seeds per acre, that population that we want. We want them spaced evenly apart so they each have their own zone and their own soil resources to go off of. And then we want to close the trench and close everything up as if we've never been there. Basically, we want this miracle to happen in the ground, that we put seed in the ground to the proper depth, proper spacing, and then want it to look like we've never been there. So that's the mindset of what we're looking to do. And there's a lot of things as far as the maintenance and wear and mechanical pieces that go into making that happen that can disrupt even the best technology or the best intentions that we have as farmers to get that done. So a couple of things I do want to talk through a little bit. We're going to focus a fair bit on emergence. So one thing that I just want to talk about a little bit is if you have a plant that is one leaf collar behind in emergence coming out of the ground, that is about a 50% loss in yield. So if you have one, and that's that generally, if we're thinking in corn, it's true for a lot of different crops. It's true in soybeans as well, but that 50% or that one collar behind, generally that's the 24-hour time frame, or our growing degree units, it's close to that, but somewhere in that time frame, you're a day behind coming up, you're a leaf collar behind, you're going to lose about 50% of yield for that plant. If you're 2 leaf collars behind, it's 90 to, I would say, 100% loss in yield for that particular plant. So if you think about it, that you've got if you're planting 1,000th of an acre, if you have one mistake in that 1,000th of an acre, you can be looking at a 50% loss or you're looking at a couple of bushels loss on there. So that's the mindset that we want to mitigate. We want to remove this type of of issues that we can be caused by planter maintenance. So I'd like to get rid of that aspect of it. If we can eliminate that before we ever get to the field, that's kind of the mindset of where we're going through. How do we eliminate late emergers? How do we eliminate spacing issues? How do we eliminate singulation issues going through it that are caused by a maintenance issue? We have the best technology on the planter, but what is it that can shoot down the best technology. So that's kind of the mindset of what we're working off of. Again, one thing I just will mention here, you see at the top, a lot of what we covered today, we have a website, we have documentations and good videos about this as well at precisionplanning.com/maintenance. That is a great resource for you guys to go take a look at. If we don't cover it today, that's another resource to take a look at. So let's back up and we're going to take a look at the planner here. Where do we start with planner maintenance? And the way I always start when I get the planner out in the first thing in the year, one of the first things I want to do is I want to set the bar up. Now it goes into hooking the planner up to the tractor. A lot of times, in this case, you can see we got a mess of hydraulic hoses up here. I always struggle with it because which hose goes in which outlet, which goes in which remote, do I have them flip-flop? I always like to recommend maybe this year you guys get them all hooked up the way you want them to, label them, mark them with something so we can actually remember for the next year and coming years, because there's nothing worse than hooking up a set of hoses and having us blow a back seal or run a motor backwards because we forgot to hook something up correctly or we hooked something up backwards. So hooking up the hydraulic hoses. But as you go across and you get the planner out for the first thing in the field, one of the key things that you want to make sure you get right, and that relates to this actual 7x7 bar. To run a planner, one of the most critical things, the first setup things that I want to make sure is right, is I want this bar to run level through the field. So as I set the planner down and I take off and I go across the field, I want this bar to be level. One of the best things that I've done is take a level, set it on top of here, on top of the bar itself. And as I set the planner down, I want to see where it's at in there. A good way to do it is actually have someone walk alongside the planner as you slowly roll through the field, just to see where that see where the bubble is at, to see if you're level as you go through the field. Bigger question is, how do you adjust that? How do you get this bar level? So that comes back to your hitch height. In this case, with the drawn planner that we got with the 1760, that's the adjustment piece up there on the yoke. You got all those different bolt holes. You can move that up and down. If you have a 2-point planner, you're going to, with 2-mounted planner, like a 1770 NT or a Case 1250 or 2150, those are going to be on 2 points. You want to raise and lower your 2-point hitch to accommodate that. A key thing with that is also that you set that to have no draft on your 2-point hitch. If you have draft on your 2-point hitch, it's going to go up and down as you go across the field as you hit various contours. So when you set your tractor up for the spring, if it was doing tillage the fall before and you're going into springtime, make sure you have that set to no draft. You don't want that to move. 3-point planners. There's a little bit different aspect of probably not a lot of 3-point planners with no-till, but one of them is that you would not set the bar based on the 3-point hitch as far as up and down. You set it by the top link of your 3-point. So rotating the top link back rotates the bar back, pulling it forward rotates the bar forward. Setting the bar height is an important piece, or setting the bar angle is an important piece with that. So those are a couple things. Why does it matter that it is level though? Well, if you take a look at your row unit here, if this bar is tipped forward, what it actually does is it takes your parallel arms and it takes this point here and it tips it forward, takes this point and tips it forward, which then sets your disc opener, your whole row unit. Now it's sitting forward on its nose. So your row cleaners are more aggressive. Or if you got no-till coulter, that's going to be more aggressive. Your disc openers now are tipped forward a little bit. Your gauge wheels are sitting behind it, so it affects your depth because your gauge wheel is sitting back here. So if everything starts to tip forward, now you're starting to change where your disc openers are in relation to the row unit. And then it really makes a big system. So this is a pinch style closing system. It's fairly close to your trench. That's not it is affected by this. But if you've got something that's in here, let's say a yetter in between 2x2 coulter, or you've got fertilizer attachments in here, now you're pushing this even further back and your closing system's back here. If the closing system is this far back and you tip this whole row unit forward, now you really have adjusted and affected your closing system at the back of the planter. So it's important that this is level. If you tip it the other way and tip it back, you just reverse the mechanical advantages. Now your closing system's too aggressive. You're affecting your depth here, and your whole row cleaners is not coming up here. If a floating row cleaner, it's not as big a deal. You can adjust for that a little bit with your row cleaners, but you really have a lot of problems with this back end, on the back end of the system. So it is important to get this bar level to maintain consistency with the row unit going through the field. And that's true whether it's this color paint or a Case system or a Kinsey system. All row units, you want them running level. Parallel arms are designed to run in parallel. You want the whole row unit sitting there running flat through level across the ground. And so that's the first part of bar setup that we want to talk through. The second piece of maintaining a bar or setting the bar up for success in the field is I want to take the bar, and one of the ways that this planter is lifted, so it's a little bit hard to do this, but generally you want this bar, when its planter is lowered, to be 19 to 22 inches above the ground. So if you set the planter on the ground, you want the bar to be close to that height. The reason for that is so that the parallel arms on the row unit are running level all the time. If they're not, when your parallel arms are running uphill or downhill, it's changing the amount of force. If you've got a spring system or an airbag system, when the parallel arms are at the bottom of the travel, that's a different amount of force than when they're sitting level, when they're sitting in a perfectly parallel scenario, because as they come up, the springs or the airbags will start to change with it. So setting the downforce right, you want that to be level in the field. So change that by setting your bar height. If the bar height isn't set, well, in addition to just using downforce springs, if your bar height is set too high, you're going to run out of travel when you go over terraces on the bottom end, or you can run out of tire problem on the top end, where you don't have enough row unit travel to accommodate the terrain. So if you're in rolling ground, a lot of you no-till guys have probably got some rougher conditions to plan into. Getting your bar set to the minimum, the middle part of your row unit, so your row unit has the most travel available to it, is pretty important to make sure that it maintains consistent. And you're not running out of row unit travel, you're not hanging the row unit in the air, or you're not pushing the whole row unit down or holding the entire bar on the row unit. So getting that height. Now, one way you can do this is to measure it off of the disc openers or the tape measure and do it that way. Another way is just to set the planter down in the field. We'll start rolling forward with it and have somebody walk alongside and see how level your parallel arms running through the field. And again, do that across the entire planter bar, not just on the outside of one row unit. Make sure the entire bar is level from left to right. Especially with a 3-point planter, you can easily get your draft arms to be a little bit out of whack. So make sure the 3-point setting level, because you're dealing with 30 foot or 20 foot, whatever it is, to balance it out. So make sure that you get the parallel arms level as you go across the field to maintain consistent down pressure on the parallel arms, and also to maintain full row unit travel up and down. The next question that I want, or piece I want to talk about with the bar height or bar planter setup, is actually related to ballast. So I have a hydraulic cylinder on this one. This is capable of 600 pounds of pushing the row unit in the ground. Airbags are generally capable around 400 pounds. Springs, you got adjustments in between 100 to around that 400 pounds as well. So pushing down, if I have, when we say that that's 400 or 600 pounds, what that's actually referencing is that I can take 400 pounds from this bar, the 7x7 bar, and push on the row unit to push that disc opener into my hard or firm dirt, whatever, to get the depth that I'm looking for. If I'm going to push on this bar with 400 pounds on one row, and I got 8 rows on here, and all of them are pushing the same height or same pressure, I've got to have that much weight on the bar, total weight on the bar, to be able to push those row units in the ground. If I don't, and this row unit is sitting in hard dirt and it doesn't go in the ground, this bar will raise up, will lift up, and it'll come to where it hits the stops on this. So it's vitally important. If I'm going to push it in the ground, I've got to have the weight on the bar to do it. So ballast is going to refer to, how do I have enough weight across the bar? If I have a central fill planter, an NT planter with a boxes on it, or maybe I have liquid tanks on it like this one does, I've got probably enough weight in the center of the planter to keep it on the ground. But on the wings, as I get out and those flex points start to come up and I'm getting more rows out away from the center of the planter, the wings will start to lift. We call it a smiling effect, where we start to get that big smile going through the field. I don't like it when my planter smiles at me. I like smiling, but I don't like smiling my planter smiling. So in order to compensate for that, add weight to the bar. That's the only way to maintain that, or you're going to have to decrease how much pressure you have on your downforce system, on your springs or your airbags, to maintain the bar it is. And at that cost, if you decrease the pressure on those, now you're running the risk of planting shallow, which is not your planting depth of 2 inches or whatever you set it to. Some guys are hanging suitcase weights between the row units. You can get a bracket and try and hang a suitcase weight or a tractor weight between them, the front of them. Some smaller planters like this, where the bar is easy to access. I've had guys that have filled it with re-rod or the cheapest steel you can get. Some guys have filled it with concrete, trying to get enough weight in here to put the bar, to maintain enough weight to push down the road. If you have liquid tanks, that's a great option. Fill the liquid tanks up. If you're not using them for fertilizer, fill them up and let them be the extra weight to push it down. Markers. A lot of us are getting to the point where markers are used sparingly, if at all. A lot of times they're cumbersome. They're in the way on a lot of things. They're easy to just take them off. I don't want them anymore. Thanks to GPS guidance and systems, we don't necessarily need them on every planter. But they play a vital role in ballast on a planter. We want that weight out on the bar on the end of the wing to keep that bar down. That's a lot of weight that's on that marker. So we would like to keep that either, if you take the markers off, you need to add the suitcase weights or add the marker weight kit to put more weight back on them. I know Deere and a lot of companies actually have a marker or have a weight kit to add to the wings to put the bar down. So Joel, do we have any questions at this point? Nothing so far? All right. Check my list here, make sure I'm getting this. Okay. Oh, I did mention the one thing, things I forgot. When you get to changing your bar height, to actually change the height of this, this is done. You want to do this in field because this can change in a no-till environment versus a conventional till environment. You got different heights. So if you just got the planter in from another customer or from you just purchased a used planter, that bar height could be very different based on what it is, if it's going into soft ground versus on firm dirt. So, and then to change that, you actually have to change the transport wheels. There's bolt holes, different bolt holes. Like a Kinsey's got 4 different holes on the main transport frame, and then the DB planters and Deere planters as well. You can change the transport wheels to change that to adjust the bar height to what you need in field. All right, Joel, we do have a question. How much weight should be on a row unit? That is going to be dependent on what ground conditions you're running into and how much weight is on the bar itself. So what you're actually looking to do is, Joel, we'll slide around over this way real quick here. We'll slide down to this row unit here real quick. What you're trying to do with any row unit is trying to get the weight to sit on, basically get the row unit itself to sit on your gauge wheels. And so if you're sitting on your gauge wheels, that means you're going to hit the depth that you've set on the planter. So where your T-handle is set to, if this is set to 2 inches and you want the weight on the gauge wheels, that's what's going to set the actual depth of the row unit itself. So you will want whatever weight it is necessary to push the disc openers into the ground to that point. That's going to be dependent on a lot of variables of how full the seed box is, how soft and firm the ground is that you're planting into, what depth you're planting to. Those are all parts of that. The way I would check that, if I don't have a weight pin or something to measure how much weight's on the gauge wheels, set the planter on the ground and take off across the field, and go 500 yards, and then get out of the cab, walk back and see what kind of imprint is the gauge wheel leaving next to the row. Can I see that it maintained contact with the ground for the entire pass? And then I also want to take the furrow and start chipping away at the furrow a little bit and see how firm the sidewalls are. I want it firm enough to hold the trench open until I get seed to it, but I don't want it so firm that it doesn't crumble when I poke it. A good way to do that is actually to pull the closing system up as well to evaluate the firmness of that furrow when you run that. But you want to make sure that this stays in contact with the ground. So the question is, well, how much weight should be on it? It should be whatever is required to keep the gauge wheels on the ground without being too heavy that you're going to compact the sidewall. All right, good question. Any more, Joel? Okay. No more questions. All right. That covers most of the planter bar setup, the main genetic planter bar setup. Obviously, you want to check for marker weights or any of the hinge points, make sure that everything looks good on that. Let's move on to the actual row unit itself, since this is where most of our focus is going to be spent. The way I like to think through it is planter bar, then go front to back across the top of the row unit, front to back across the bottom of the row unit. So we'll move from here across the top, come back and go across the bottom half. As I look at this, the first thing that's going to pop up is the W plate parallel arm linkage system, kind of that whole concept here. Parallel arm wear. We talk a lot about that in precision planting. We've been through quite a few systems. If you get wear inside of a parallel arm, and we'll talk through what that looks like exactly, but what you can actually start to see is you can grab the back of a row unit. This is a good way to test the system. Grab the back of the row unit and pick up on it. Anytime you start to get some play in it, this one's not terrible, but it's not super good. It looks got some decent amount of wear. We went through and we leveled the bar, right? We went through and made this bar level so that these are running parallel, so the row unit's running flat level on top of the ground. If I have parallel arm wear, as soon as this row unit hits the ground, that's the resistance point is up front. The whole row unit's going to want to tip up, stand on the front end like this. If you get wear, now the whole system starts to tip forward again. Now that's again causing issues with our closing system, causing issues with the depth, causing issues with the no-till coulter out in front again. That's starting to tip the whole row unit forward on its nose. That also creates a couple other issues in the system as well. One is that wear and that chatter, you get that side-to-side movement. I've lost, if you get side-to-side movement as well within the parallel arm bushings, I've lost precise control over this row unit. I don't have a consistent response when I put pressure on the gauge, on the downforce cylinders. I don't have a consistent response based on side-to-side wear. The row unit's not following true. It's not precise. I don't have full control over it. One, there's two ways I like to think of this. One is it kind of reminds me of my 2-year-old trying to put my boots on in the house and trying to walk with it. They might move and take a couple steps, but the minute they try to make a fast move, they're flat on their face because they don't have control. They're oversized. The boots are oversized for them. They're going to trip over themselves because they don't have full control over it. The other way you can think of this, and this might mean a little more to you guys, it's like trying to pull a grain cart with a 1-inch pin and a 2.5-inch yoke. Every time you move, that thing's slamming against each other because it's popping each way. That's what's happening if you have parallel arm wear in this session here on either one of these, either in the goalpost or the parallel arm, the lower parallel arm, the upper W plate here, all that wear, bolt wear, you now don't have the concise, crisp control over the row unit, and it's going to start chattering. That affects the spacing, affects the depth going forward, affects your closing system, and eventually will affect your overall performance and give you some of the late emergence. But Joel, let's take a look and see what this wear actually is, because it's cost money to replace these wear parts. These are expensive pieces that we're talking about. What does that wear look like? When do I need to replace it? So one is to do the check on the row unit, see how much lift you get. But if you take a look at the parallel arms, this is a brand new arm with a brand new bushing. There's almost no wear on that. If you get close enough, you can see there's just no wiggle. That's a tight fit. So that one's good. Let's take this brand new bushing and put it in a worn parallel arm. So this actually is not even what actually should, this is better than what was here, but this is a brand new bushing in a worn parallel arm. Look how much slop you got here. That's going to cause a problem no matter what you go into. That lower parallel arm, this is a dear lower parallel arm, this needs to be replaced. Even a new bushing won't fix this issue. You're going to get a lot of slop and movement within that row unit just because of how much wear is in there. So stop that bushing from running away. So that is what the one looks like. I know there's some money involved in that, but those are things that are going to affect your depth. It goes back to those late emergers. What's that 50 or 100% loss if we get something that's wearing on there? So there are other kits out there. Some of you guys said, well, it's expensive to replace a whole lower. You're right. It does. There is some money in replacing the whole lower parallel arm. There are other kits out there that you can use, retrofit kits that either are drilling these out, putting inserts in them, hardening bushings. There are several different options out there that are good options that will work to help alleviate that issues within the wear in the parallel arms themselves. All right. Any questions on that? Got a question coming in? All right, so the question is, if I have gauge wheel sensors, how much weight should the gauge wheels carry? It's ground or harder ground makes it harder, makes more pressure to penetrate, but the weight carry on the gauge wheel is going to be fairly consistent. That should be true. In our opinion, if I'm going to put weight on the gauge wheels, a safe number for me is to carry about 100 pounds of weight. If I could get that accomplished at all times, I would carry about 100 pounds of weight on the gauge wheel. There's some differences across those. A case system, you're probably going to carry a little bit more than that. And we'll talk about that in a little bit later in the session, why they carry more. But the idea that I would want to carry is about 100 pounds. That's not so much that's going to compact the sidewalls, but it is enough to maintain consistency across the field that I would be able to do. That's if I've got a control system. If I don't have a control system to it, I'm probably going to run that 150, maybe up to 200 pounds of weight, depending on ground conditions, just to make sure that I maintain ground contact across the entire field. All right, one more question. Are Disc openers. Since the question about the disc openers, what is the correct time to change a disc opener if it was 15 from new? I will get to that. Let's hold that question for just a moment. I will come back to that one in a little bit. All right. Any specific questions related to parallel arm wear, Joel? Or parallel arm? Okay, good. Good questions on those. I will come back to the, if I didn't answer the downforce question on gauge wheels, let us know and we'll try to address it again. We'll come back to disc opener wear as well. All right. So as we move along, the next step is going to be the metering system that goes into it. I'm not going to break apart the entire meter, but what I'll tell you this is take your meters out to get them tested. You want to make sure that they are capable of running at the performance that they can. So Deere meters, Kinsey meters, all of those, I would take them out to either a precision planting dealer, have them ran on their test stand, or some of your Deere dealerships have their own test stand. I know Kinsey has their own test stands. Make sure that they are running capable. If you can take the seed that you're going to plant this spring, that always helps them be able to calibrate that meter and give you the settings that will allow that meter to perform at its best for that spring with that seed. A couple of things to check is if you've got a vacuum system, double check your vac systems. It's not uncommon to have stuff get plugged up inside your vac tubes and your vac hoses. A lot of times I've chased down an issue with a vac meter that is related, totally unrelated to the meter performance, but 100% related to a vacuum system that's not giving me good vac, whether there's a rat's nest or mouse nest that plugged up one of the hoses or something getting stuck inside there. Check those systems out as well. So calibrate your meters, make sure they're cleaned up and ready to go, make sure you can get a test in. The other piece of meter performance is the drive system. Now, this planter has electric drives on it, and there's a lot of you guys that have other drive systems out there other than chains. But make sure that they are set up well. Joel, we're going to slide over here to this older row unit here, this row unit stand, and take a look at a chain system that's set up. It's an older 7000. We just have it set up here. This is your chain system that's set up here. My favorite way to take care and to work with chains on the planter at the beginning of the spring is to take a bolt cutter, come out here and snap this chain in half and cut it in half, because that does two things. One, it's an easy way to get the chain off. Second of all, it removes my temptation to reuse that chain, or grandpa's temptation to reuse that chain. Most chains that are been out there for over a year, I would like to get rid of them. They've been sitting in the shop. They've been gathering moisture. They ran for a whole year last year. They start to show wear. One of the quick ways to check this out is to pull a chain and lay it next to a brand new one and see how much stretch you have in the same number of lengths on that chain. That'll make a big difference as far as that'll kind of help you see how much stretch it is. If that chain stretches, what you're doing is you're not sitting in the pocket of the sprocket anymore. When you go around on each tooth, you're not sitting in there. It's got to roll into it. Every time it's got to roll into it, it creates a vibration that gets transferred to the hex, the drive of the meter, which gets transferred to down the seed tube. That vibration of any chain causing issues with it, whether it's not being tight or it's gotten to fit into the socket, the pocket of the sprocket, creates a vibration in the meter, which creates delay. Even if it's a millisecond of delay, that creates a spacing issue in the meter performance. So that's one aspect. The other aspect is check the bearings, take the hex shafts off. What I like to do is take the chains off, spin all the hex shafts and make sure they spin freely. Make sure there's nothing catching, that you can't catch a bind in the bearing as it goes through. So take the chains off, run your hex shafts. If you got a cable drive that runs through here, a lot of cable drives in the systems, make sure they're free and they spin easily and they're not, as they sit in position, that they're not twisting and binding, that they don't have a tight spot in them. So check the bearings here. I also like to check the sprocket and the bearing on the at the drive on the side panel, and then also your chain tensioner. This one's actually frozen up. If you look at this, I can't actually move the tensioner on this one. So this is actually not a good system, functioning system at all. So those are a couple of things I would look for as far as this. And there's a lot of different options out there as far as chain goes as well. I say pick one that you're comfortable with, but always inspect them and get them ready for spring. I think that's all I've got on chains. Joel, any questions coming in so far?
Are we going to level the bar differently when we have hydraulic downforce?
Okay, so the question is, are we going to level the bar, the planter bar differently if we have hydraulic downforce? And the answer I would provide is no. The same concepts, whether it's a hydraulic downforce system or an airbag system, I always want the bar to be level at the same time. Basically, the only difference that I would make sure is I would want it to be leveled in the field when you're running across the field, so that you don't, as you're applying pressure to as that hydraulic downforce is applying pressure to the row units, it's not tipping the bar up or tipping the bar back, anything on that nature. So as long as it's level when you're running across the field, that's the goal that I would do, even with the hydraulic downforce. All right. Move on to my next section here. The one last thing that I want to talk about on meters is actual C-tube wear. This is something that we want to cover fairly quickly here. Double check your C-tubes. Make sure there's no, this creates spacing issues. If you take, I got two C-tubes here. One is more worn than the other. If you look at this one here, there is starting to be wear on the edges on both sides of this. This one's not bad. As long as my disc openers don't contact the C-tube again, this one should be okay. But you can see how thin the plastic's getting. Once this wears through, the plastic here will start to tip come in. And when it does that, it'll obstruct the seed as it goes down the seed tube. If you look at this one's still got plenty of plastic on both sides. This one's not worn at all, but I always like to check these, make sure there's nothing in the bottom of the seed tube. If there's any edge or burrs in here, file them off, get them cleaned up again so they're not disrupting the seed. So, all right. All right, let's move down to the bottom of the row unit. We're going to go down to the front edge. We kind of covered this. Actually, we'll just quickly check on insecticide systems. If you've got them, calibrate them, clean them out, make sure everything moves, chain works on those. That's about the extent of what I've got for insecticide systems. As we move forward to the bottom half of the row unit, this is where the stuff starts to get, we go through a lot of things here. This is your row, make sure your row cleaners are free, make sure they move up and down. If they're not bearings, the C's aren't tight here, you're bearing, your discs turn easy up front, far part of that. The biggest thing that's on the front edge of the row unit that I'm concerned with, especially with no-tillers, is that no-till coulter out front. Make sure that no-till coulter is set up to run above the bottom of your disc openers, not below the bottom of your disc openers. It is important that I would recommend it to be a 1/4 inch above the bottom of your disc openers. If you go below that, what you run the risk of is that the disc openers or the gauge wheels or the no-till coulters going deeper than your disc openers and then creating air pockets underneath where you're dropping seed. If that's the case, now I have a tough time closing it, or I have an issue where I can get seed that falls deeper than my actual planting depth, the desired planting depth. So then I get variation on emergence because some seeds are deeper than the other seeds. Set that disc open, that no-till coulter, no more than a 1/4 inch or no deeper than a 1/4 inch above your disc openers. I'm not a big fan of no-till coulters as a whole. My biggest thing is I think a proper downforce system. I'm not decreasing the amount of downforce I'm applying. I'm actually spreading it across 2 areas now that I'm trying to push it in the ground, because I still have to get these to the same depth. My estimation is that a good downforce system will apply enough force to get 2 disc openers that are shimmed correctly in the ground. The V disc opener should get in the ground with no issues on it. There's variations on that. I will say that putting a no-till coulter out front can reduce the amount of stress on your disc openers as far as how much wear and tear they hold, but I'm not as much of a fan of on the no-till coulter for that reason. I think we can accomplish most of what we're trying to do with a no-till coulter with a good downforce system on the actual disc openers themselves. So they can work well. It's a little bit more maintenance. It's more settings, and it creates a little bit more room for error with it. So that's a little bit on no-till coulters. I know that a lot of you no-till guys really like that no-till coulter just to do a little bit of tillage out front, break up some of the residue. I'm not, especially with row cleaners, you want to make sure that you clear the path ahead of that no-till coulter, because if it doesn't, it can start to hairpin residue down into the bottom of the trench, setting it up to get stuck next to the seed. So if you're running a no-till coulter, I would also recommend running a row cleaner, especially in heavy residue conditions. All right, so no-till coulters, moving back a little bit, we're going to get into disc openers as in setup on disc openers. Are there any questions, Joel? Is there? Okay, good. All right, so when we get to disc openers, I'm going to reach up here. I got 2 business cards. One of the biggest things that we want to see with disc openers is that they're shimmed correctly. And so whether that's a brand new disc opener or whether that's one that you've had on the planter for a year, but what you want to do is shim it correctly. You're going to pull a business card. This is the way we like to shim them. Slide them forward. And what you're looking for is to establish how much contact do these disc openers have at the front to create that nice crisp V in the trench. So take one business card from the front, come toward the box, and come from the back side here. Let me grab my tape measure real quick here. Got to grab this. So as I come in here, what I'm going to do is I'm going to measure from this point to this point and see what we've got here. And I measure across here, about 2 3/4 inches. So I got a fair bit of contact in there. Each radiant is going to be a little bit different. And we'll cover each one of them is. But once I check that disc opener measurement, I'm going to actually take the disc opener. I'm going to spin them because each disc can be warped a little bit, especially if you've got something that's been installed and ran for a year. I would want to check those and make sure that they're consistent on both sides. Even if you have brand new disc openers, I always recommend checking them because they can get brand new disc openers that work. So if I slide this one up here, slide it to where it contacts, so it's tight. And on this one, I'm right at 2.5 inches. 2.5 inches of contact. So that's not bad. That's actually pretty good. We're going to go over to the whiteboard real quick, and I'll talk through what each one of them is. But that's the best shimming and the best amount of contact that we have on the disc openers that will allow us to get that proper V set to the bottom of the trench. So what's the difference in when do we have a different set of contacts for each one? That comes back to blade thickness. So a 3 millimeter blade is 2 inches to 2.5 inches of contact. If I have a 3.5 millimeter blade, it's going to be 1.5 to 2 inches of contact. And if I have a 4 millimeter blade, it's going to be 1 inch to 1.5 inches of contact. I'm personally not a big fan of this 4 millimeter blade. It's a little bit too thick. What you're compensating for, why there's differences in each one of these is because as you get a thicker blade, thicker blade, you've got more stress, more tension on that bearing. You'll override that bearing if you run them too tight. It'll start to create a lot of excessive wear on the bearing itself based on how much contact. If you take this 4 millimeter bearing and try and shim it that tight, you'll actually break the bearing hub out itself. So it's important to look for these. A lot of your dealerships, when you go in and say, hey, I want new disc openers, they say, hey, you're a no-till. I've got a heavy duty disc opener that I can sell. You want heavy duty disc openers? That generally means 3.5 inch or 3.5 millimeter disc blades. That's generally what they reference on those. So on this one though, that is the mindset of this is that it should be shimmed to 2 to 2.5 inches of contact on a 3 millimeter, 1.5 on a 3.5, and 1 to 1.5 on a 4 millimeter blade. The other thing about the 4 millimeter blade that I'm not as big a fan of is that the bevel edge. So that very edge, when you got a disc opener here like this, that very actual bevel on the outside edge gets really, really small. So you don't have as much edge. You got a dull blade fairly quickly on that 4 millimeter blade. All right, the question came in earlier, when do you replace the disc openers, or what stage should they be replaced? It's a great question. So a new disc opener, this is a brand new one this is a Deere disc. It is 15 inches from new. Generally on most systems that I've been around is a 1/2 inch of wear. So if I take a used disc opener here, this one's actually not too bad. This one's actually at just under 13 3/4. So I would probably be okay with running that one more year, depending on how much wear I get, how many rotors I get on a single system. But at 14.5, if I'm close to that 14.5 to start the season, I'm not going to attempt to run that another year. I'm going to take that disc opener off and I'm going to replace it with a new one. So each variant is going to be slightly different, but there's quite a few that are that 15 inches, the kind of the common one. There's a few things that we'll write up here that are for different row units. So a John Deere, oops, that marker is not very clear. We won't use that one. There's my black one. So a John Deere, a 2100 case, a 8000 white, and then let me think here. I'm missing one more here. Kinsey. These are all 15-inch blades, from new, and they will be replaced at 14. Oops. At 14.5, they need to be replaced. A 1200 series case or 5 series row unit, those are 14 new, replaced at 13.5. And then the last one that's a little bit different is the 9000 white, or ag code row unit. That one is 16 new, replace at 15 and a half. So you can follow my chicken scratches on the whiteboard. Mama never said I was a great artist. I can draw, but not very well. So to the questions of when to replace them, there is some conversation around the 8,000. Some of the 8,000 documentation, I believe, will actually say you can run these down to 14. I preferentially would probably replace them to 14 and a half. 14, if you take it all the way down to 14, you're running the risk of damaging the interior components inside the row unit. If you take them past the 14 and a half or this half-inch general half-inch of wear, what you're starting to do is you got to shim them tighter and tighter and tighter to get them to fit within the row unit, to get that 2.5 inches or inch to 2.5 inches of contact. To get that kind of contact, you now are getting the disc so tight that you actually start to wear on the row unit itself and start to damage the row unit components, the actual hard shank piece of the row unit. So, all right, disc openers. Any questions, Joel? Do we have questions come in yet?
Is there a specific tile of no-till coulter you prefer?
Specific tile of no-till coulter that I prefer. I believe that's referencing to the how many flutes each one has. It's not. I'm not too picky about those. The thing that to remember on those is that on the no-till coulter, the less flutes you have, so a 13 bevel or 13 bubble no-till coulter versus a 25 or the 30s, is how much rooster tail you get. If you're going to run fast, you're going to run that 5, 5.5, 6, 7, 8 mile an hour. Go to a higher bubble so you don't have as much dirt and debris flowing out of it. If you're going to be running slow, you can go to the less flutes to try and maintain to get more of a tillage action with it. So those are generally what I would say as far as style of no-till coulter.
Would you ever sharpen a disc opener?
So another question is, would you ever sharpen a disc opener? If there's generally, I haven't seen a need to. You can. I don't have a problem with if somebody wants to. It's not an issue that I would see, as long as the wear of the disc opener is still good. As long as it's got enough distance on it, you could sharpen them. I haven't seen a need to do that. Most of the times that I've seen them, the bevel is still good enough. The sharpness of the blade is still good enough, given how much diameter they are. Once they get past that 14 and a half, I generally start to see that the bevel has disappeared as well. But they're short enough, small enough by that point that I'd replace them anyway. So not a problem. But yes, I would. You can do it if the disc is big enough.
I know we're going to closing system soon. Do we adjust closing system differently with a full or empty seed box?
So the question is, the closing will be done at some point, but do we adjust the closing system based on a full or empty seed box? We'll talk about that. Let's hold that conversation until we actually get to the closing system. Any more, Joel? Okay. All right. Another question we have is on C-tube guards. So we talked a little bit about C-tubes a little bit ago, as far as how the wear on a C-tube. But the C-tube guard, this guy here is what we're referencing. This is what a brand new one is. This is a worn one. But this does two purposes. One is it actually does protect the C-tube. So if you sit your C-tube down in here, this is a protection to keep it from the disc openers from wearing on the guard itself. So that is one functionality of it. But another functionality of it is it sits against the inside of the disc openers. They ride inside the disc openers. And what they're actually doing is maintaining, and get rid of some of these drawings here. What you're actually referencing, what we're actually like to them about is we want a nice big V trench with our seed that can sit in the middle of this. If you have a narrow trench, and that's what our disc openers are trying to do. We're trying to create that V going through the furrow. So we want that V. If we don't have our disc opener shimmed correctly, you actually get a furrow that looks a little bit like this with this W bottom to it. And that C can actually sit on top of that W bottom with an air pocket underneath it on each side. Now, Keaton can help alleviate some of that, but that's one of the reasons that we stress so much about the shimming to make sure that they've got the contact to create that V trench and to eliminate this W bottom at the bottom of it. But we want to widen the trench to the bottom that Seeking has no trouble getting down to this. Or Keaton can push it on down if we have those, or a rebound or whatever it is that can push that seed to the bottom of the trench. If the seed guard is actually worn, what you start to get is a pretty narrow trench, because this is actually holding the disc opener. We've got force pushing on the disc openers, trying to push them in. Because when I got firm dirt on no-till, I got both sides of this is firm dirt. As I'm slicing through the ground, there's firm dirt trying to push this disc opener in and this disc opener in. There's enough flex to those disc openers that they can start to get narrow up. And then I get a seed that's way up here, and I have a tough time getting to the bottom of the trench. I get a real narrow seed trench. This disc guard, or C2 protector is what it's been called, is actually holding these disc openers apart to actually create a wider trench at the bottom of it, so we can actually get seed all the way to the bottom of the trench. So this is a dual purpose piece. It is important to keep an eye on this. And my experience is that this actually is probably going to wear out before your disc openers will. Most of the time that I've seen this will wear quicker than what your disc opener diameter will wear. These are new, so a deer system is going to come in basically at a 1 inch from new. At 3/4 of an inch of wear, I would replace it. This guard here is actually, I believe this is about 11/16 of wear. It's about 11/16 down. So this is under the 3/4 inch mark. I would replace this. What this is actually, this actually came off of the same row unit as these discs. They were replaced at the same time. So this guard actually wore under the 3/4 inch and basically a 1/2 inch of disc, or a 1/4 inch of disc opener wear. So this is more likely going to be the first thing that you're going to replace before your disc openers even get to that point. So disc opener guards. Now, a Kinsey is going to operate very similar to the same way on this, but let's take a look at the case, because the case has something very different in scenario to operate on these. We've talked a little bit about case as far as they've got a little bit of a different scenario, but with the shimming that we all mentioned as far as disc openers and stuff was specific to a pinch style or normal true V opener. Case doesn't have the true V opener. You guys are aware of that. Cases runs a center trailing disc, so leading edge disc. So you got one disc out in front of it and disc behind it. They tucked in behind each other, kind of in a V, kind of behind this. The thing that makes a big difference then is they actually have this shoe that comes down here that actually forms the trench itself. This shoe holds the trench open on both sides, and they've got a firming point up here in the front that actually, not a firming point, a forming point up in front that actually forms the bottom of the trench to make sure it's wide enough. And then this shoe actually holds the trench open long enough to get seed to the bottom of the trench. So there are some wear pieces on this as well. This shoe can wear out. This is evidenced by this piece here. You take a look at this. This has got significant wear on the side of this that can actually wear. Once you start to wear into the side, your disc openers will rub on the side of it. You're leading your trailing edge. That's going to wear them out. Now, these can be rotated from side to side, from row to row. So a trailing edge disc would be on this, could be on this side, or a leading edge could be on this side, and you can take it from one side, half of the planter to the other side to accommodate for that wear in those. But that is one that is wore out. So I'm going to go ahead and take this piece off, because the other piece about this that I want to talk through is the forming point of the front can also wear. So I take this off. Now I can take the forming point out and set this down. This is what a new and a good shoe looks like. You use contact on both sides. This is a good firming point. It has nice and good sharp points to it. But what you actually want to check on this one to verify what is good and what is not is you need a check gauge from Case. They call it a furrow forming point gauge. And you take it and you slide the point of this directly into the slot. And there's a little window on the back side of here. You can see that, Joel? This little window, if you don't see the steel coming through that window of this firming point here, if you don't see that forming point coming through the steel, you need to replace this firming point as Case's spec. So that's another piece to take a look at that you want to wear. This is kind of the same thing as my disc opener guard on a Deere or Kinsey row unit or AGCO row unit on a True V. You want to make sure that this piece is getting replaced as necessary to accommodate for the wear points within that row unit. All right, I'm going to set these aside for a moment. Any questions so far, Joel? Not at the moment? Okay. All right. Set back up again. As we talk through the furrow point, one of the things I would actually recommend you guys do in season is that we go in and we actually pull up the closing tail and double check to see what this furrow looks like. Pull the closing tail up, start to run a pass and see what does this trench look like. Is it squeezed tight like this? Is it big and wide like this so you can get seed to the bottom of the trench? Are you getting a W bottom to the bottom of the seed trench where you're getting this little V, this little mini V in the center of it? This is going to cause problems with because you can't get seed to sit. You got to take care of this cap in here that's adjusting your depth. And depending on where a seed sits, it might sit at the bottom of it, it might sit on top of it. You don't know where that's going to wind up as. That's a problem. That goes back to your shimming aspect of it. This narrow trench goes to your disc opener guards causing a problem. This is what we're looking for. So evaluate the furrow, evaluate how well your disc openers are creating that V. They're slicing through the soil, cleaning the residue off the way, out of the way, making sure there's nothing there, and then getting a good spot to put a seed in the bottom of it. All right, and that is disc openers. The next aspect that we're going to talk through is going to be what you set your depth with. So gauge wheels and your depth linkage, as far as that goes. We talked a little bit about how we want to set the depth to, we want to set the gauge wheels to be the depth adjustment, to set us on the depth adjustment. So when you set depth, so Joel, you want to slide back over here real quick. You guys set your depth based off of this T handle here on a deer row, or on a deer row unit or a Kinsey row unit, most, except for a case. You set it on T handle, it goes down and it sits on this mustache. The mustache then comes in contact with the gauge wheel arm. That's kind of the piece that actually sets your depth. When you move this, you're moving how high or how low that mustache is going to be before it contacts the gauge wheels. How far up does that gauge wheel come before it hits this mustache? What we've seen in our mechanism is that there's a lot of variation from row to row on what this notch is or what this notch is. And a lot of times you actually have to adjust the gauge wheel, the depth adjustment based on what these are. So mustache wear is a big piece of this, but let's take a look at what some of the wear points are within this that can affect our depth. So first of all, here's our mustache. Here's the depth of linkage system. This is a plus series row unit. The XPs have a cast piece in here, don't have this bushing, but this, take a look at this, there's a lot of wear in here. That magnifies out when it gets into the actual how deep you're setting it. There's also wear in the mustache itself as it sits on the bolt. You'll wear the inner piece and the bolt itself. You can also wear the pads on the mustache as well. All of those start to add up to 1/2 inch to 1/4 inch, or maybe even more than that, a variation in how set depth that's set. And then the next piece that goes into this is the actual mustache itself, or the gauge wheel arm itself. If you see this type of wear, this is actually only 200 acres on a gauge wheel arm. But if you see this type of wear, that's making a difference on how deep that row unit is going to come up, because you've etched out part of it. Now you can take this over and flip it on the other side, run the other side of this gauge wheel arm out. That's also another piece of it that you can fine tune that. And then we'll come back a little bit and talk about how tight this is. Is there wear in the pivot arm, pivot assembly? That makes a big difference in how you set your gauge wheels. We'll come back to that in a little bit. So that is the Deere system. Let's step over here and take a look at the Kinsey row unit real quick. So the Kinsey row unit has a little bit of a different mechanism that's going to cause some issues, but it's still the same principle. You got your gauge wheel arm here. This is what's setting your depth. You got your T handle up top here that's setting how deep the gauge wheels travel. The wear points on that is actually this dog bone or wishbone inside here. It's got a ball on each end of it. It goes inside the socket on the gauge wheel arm. The ball can wear inside here. It can wear right on this D-link inside here. There's a little link that connects this piece to this piece. That mustache piece in there can wear, and then the actual socket of the gauge wheel arm itself. You'll see this piece on the inside. You take the gauge wheel arm off and you'll see inside the socket of this will actually have a lot of wear into it. All those will go into affecting how much depth or how much dip variation you get from row to row. If you set this to 2 inches, is it truly 2 inches or is it deeper than that? Because there's wear in the gauge wheel arms that go into it. And we'll call it out one more time on the case row unit. We'll slide over here and take a look at the case row unit and just explain the pieces to look for on this. So the case row unit, you have to probably come up over top, I'm guessing, Joel. The gauge wheel arm is coming down here. This is the actual depth stop on the gauge wheel arm. The gauge wheel arm comes up. You can get a pocket inside here that can wear, this is linkage across here. We only got one gauge wheel, so this little cockeye in here. But this top piece here is what catches both gauge wheel arms. You can wear the flat spot on both of these and on the gauge wheel itself. You can have wear on this pin mechanism here in the middle. And then there's also another pin mechanism back here as well on this slide that goes through the whole top of the row unit to the depth adjustment at the back down here that can cause some wear in all of these places. So those are the key pieces to check for on the case system to find out how much slop you've got with it. Now the case system's a little bit easier to adjust. You've got the key adjustment handle. You can kind of fine tune this a little bit more than what some of the other systems are, but it still moves a long ways when you move that adjustment handle. So fine tune that. One way that I'm going to recommend you guys check that is the block check. You guys have probably heard us talk about that before, but if this is my disc openers, I have gauge wheels sitting here and here. What I want to do is take a block. I like a 4x4 block. Set them on top of here and let the disc opener sit in between here. Set all my row units to the same setting in the T-handle, and then see how much variation I have from the bottom of this to my disc opener. Are all of them set the same, or are some of them going to be more than that? Here's one option that we set up because we like to do this. This is actually a preset setup. So here's my 2 blocks, my 4x4 blocks. I've got a room to run my disc openers down the middle of this. So if I set it like this, I can set it on the ground, set my disc openers in a slot, gauge wheel set on top of the blocks. How far does it come down? If you can see, we've actually got, let's see if you can see here. I got a 2-inch mark, a pen mark written on the bottom there, lined in there. That's what 2 inches would be. If I have the row unit set to 2 inches, all of my disc openers should be sitting at that line. If they're above or below that, and what I've seen is a lot of them will be, you might be 1/2 inch to 1/4 inch below that mark. Some of them might be a little higher than that mark. That's when you're gonna have to get the paint pen out and go through and fine tune each notch on the row unit itself. All right. Questions on that? Nothing? Okay. All right. Let's move on. While we're talking gauge wheels, what time we got? Okay. We've talked through a little bit of the settings on the gauge wheels. One thing I do want to talk through on gauge wheels and the setup. Let's go, Joel, let's go around the plane. I want to show you what it looks like, what an improper gauge wheel is set to, what that looks like. So we're going to slip around the planer over here. One of the key things that we want to do when we set gauge wheels. So we've talked about how important they are to setting the depth of the planer itself. So on this one, if you take a look at this, you slide, go ahead and slide around and get on the front side here. This gauge wheel, if you can pull it back and forth, see how loose this gauge wheel is. It's got a fair bit of slop to it. And if I can actually get part of my fingers behind and between the disc opener and the gauge wheel itself. Now the gauge wheel is free to move up where it's supposed to. It's going to contact the mustache like it's supposed to. It's going to set my depth the way it's supposed to. But what can happen here is that if this gauge wheel is not tight to the disc, what happens is you get mud and you get dirt that fall into and behind between the disc opener and the gauge wheel. Now, if it's dry dirt, that actually what can happen is that dirt gets in behind here. It then starts to rooster tail out and it'll actually fall on the back side of the gauge wheel. It'll fall out and on top of the seed in the trench. And then you get dry dirt on top of the seed. We've worked so hard to get down to the depth we want in the moisture. And then because my gauge wheel is not shimming correctly, I can wind up with dry dirt on top of the seed and cause my emergence issues. I don't like dry dirt on top of my seed. So if you're in sticky conditions, it's even worse. Because what happens in the sticky conditions is, then I get mud back here. And when I get mud back here, all you guys know what happens when I get mud behind the disc openers or behind the gauge wheels. I get to stop, pull them off, pull the gauge wheel out, scrape it clean, and put it all back on again. So if I get mud back in here, I want to seal this up as tight as I can. Joe, we'll go up to row 1. And I've got, we can slide around this direction here. In row 1, where we'll actually show what a good shimmed gauge wheel looks like, how it's tight to the row unit. So as we slide up here on row 1, this one, as you can see, you can actually kind of hear it starting to squeal as it goes up and down. I can turn the disc openers. As I turn the gauge wheel, I'm actually turning the disc openers as well. This one's tight. I can't pull all distance across it, but it's also loose enough that if I let go of it, it's going to flop down again. It's going to scrub the disc opener as it goes down though, but it's still free to move. This is the way I would like to have it set. I can't get my fingers behind it. I'm tight, so I'm not getting dirt and residue back in behind it, but I'm also still loose enough that it can freely float up and down. Some of the systems that are out there, you want to be careful that you want this to be free. You don't want this set so tight that you can't get good movement out of this. This should fall on its own with gravity, not be stuck inside or not be stuck up. So, key pieces of setting that gauge wheels. There's one more thing I want to talk to with gauge wheels because there are some differences in gauge wheels. I want to mention just a little bit of that. Yep. So this is a standard gauge wheel. It's got a rib on the outside edge of it. It's designed to hold the disc, the furrow, as you disc covers go through, as they bring that soil out and create that V, this is going to compact the soil profile just a little bit to maintain that density to it so it doesn't fall back in again. If I take this over to the case row unit, case has a different style of a gauge wheel. I'm going to flip this around. If you look at this, you can see the case has a reduced inner diameter. This inside edge, these gauge wheels are the same size, but the inside edge of this is smaller than the outside edge of this. This works on the case row unit because they have a boot sitting down here that's holding the furrow open. The reason they have this is so that as they go through, as the disc openers go through and they open that furrow up, there's nothing to hold that profile. There's no density reconstruction or anything to hold that soil density to compact it just a little bit to hold it open, because they have a shoe inside that's going to hold it open long enough to get seed to the bottom of the trench. If you take this gauge wheel and you put it on a John Deere or Kinsey or a different row unit, now you're trying to hold a furrow open with a gauge wheel that won't condense the sidewalls, that won't change the density of the sidewall a little bit to hold it open long enough to get seed to the bottom of it. You're going to struggle in any type of conditions that are tillage or dry conditions to keep that furrow open long enough to get seed to the bottom of the trench. So Deere systems with a standard gauge wheel, this is the best system that I've seen to keep a Deere furrow open long enough. If you run this gauge wheel, this RID gauge wheel on a Deere row unit, you're going to have some issues trying to keep that furrow open long enough to get seed to the bottom of the trench without getting dry dirt to come inside of it. So it is pretty important. I'm not a big fan of an RID wheel on a non-case planer. On a case planer, they work great because of the boot that they can hold their furrow open. But on a Deere system, I'm not a big fan, or Kinsey or Echo, normal true style V opener. I'm not a big fan of these because they don't have the boot in the furrow to keep them open. If you get really sticky conditions or really wet conditions, you can get away with this because just the profile of the V pushing creating the V to begin with will create enough density change in the sidewalls that it will actually hold itself open. But then you get in any type of dry conditions or tillage, any conventional, anything that's got just a little bit that's not really wet, you're going to struggle with that scenario. So, all right. Joel, do we have any questions?
Is it safe to assume that each notch of the handle on a gauge wheel depth setting equals a 1/2 inch? We're talking about a Kinsey planer here, but on any row unit?
So the question is it safe to assume that every notch or every half notch on the depth setting is related to a 1/2 inch of depth? From what I've seen, it's pretty consistent. The starting point for that 1/2 inch might be off. So what maybe to say is what they say should be 2 inches of planting depth might not be that. You might have to go up a 1/2 inch or down a 1/2 inch. But most of the time, what I've seen is that the actual notches themselves are generally relatively correct to a 1/2 inch in the field. Any others? Good. Okay. All right. So we covered depth checks, gauge wheel shimmings. One thing I did forget to cover on this a little bit is the actual a Keaton or something along those lines. I would recommend that you check some type of firmer that's running in the ground to push seed to the bottom of the trench. This is a Keaton here. I would recommend that you check the tension on these. A lot of times what can actually happen here is they look like, well, it should be okay, but I'm more concerned about the fact that it's wearing. Well, you can flatten them off a little bit if you need to flatten the bottom off, but what's more important to me is how much tension is on this Keaton. When I set the planer on the ground and I come back and pull on the Keaton, I want actually about 20 inch-pounds of force before that Keaton leaves the ground. Fish scales or something along those lines is probably the best option. Take a loop of wire or string, get it around the bottom of the Keaton, and then pull up on it. But I want 20 inch-pounds of force at a minimum on the Keaton before it comes off the ground. What can actually happen a lot of times with these plastics is they start to just get weak. Over time, the plastic starts to degrade itself. It's not so much the wear point as much as do they still have the tension required to get them to firm to the bottom. A loose Keaton will cause more damage to not getting seed to the bottom of the trench than a good tight Keaton will. So you want to make sure you get a good Keaton with a high force on it. All right. I think there's anything else. And then closing system is the next piece that I want to cover. Yep. All right, so we're getting close to being done. Do you have any more questions, Joel?
Are you ever concerned about too much pressure on a keaton?
So the thing about my question is, am I ever concerned about too much pressure on a keaton? The thing about getting too much pressure on a keaton, if you get into, well, actually, it starts to happen. So a mojo wire, they're applying a lot of pressure to the system. Actually, hold on one second. I'm gonna grab my tape measure before I get into that. So if you start to get too much pressure on the keaton, you can start to change your depth a little bit. If you get looser conditions, you can start to push the keaton too deep past the soil profile. Most of the time, that's not a problem, especially in no-till. You got firm dirt underneath this. You shouldn't have an issue with running higher pressure. What you will start to see more commonly is you're going to start to see higher wear on the keaton itself, which isn't a performance issue as far as agronomy issues, but it can start to be a little more costly because we're replacing the ketons more often because it actually wears the keton out. So can I get too much pressure? I haven't seen many cases that you can. In a conventional tilt system where you got a lot of tillage, you got really loose soil profile. If you get really high tension on the keton, you could start to push it past what your disc opener was set to. I don't think I've seen that actually come up. That's a theory come to. Most of the time I've seen high pressure is not necessarily a problem on the keton. All right, so let's talk a little bit about closing systems. We've talked through putting the seed to the ground, getting it to the bottom of the trench, getting depth correctly. What's the last piece that we want to do? And that's the last piece is to close the trench without any trace that we've been there. We want to put the seed in the pocket, basically look like it just magically got dropped in there. So we got to go back in that careful V trench that we were so careful to create. We now need to close that back up, make it look like we've never been there at all. And so we want to make sure we can actually accomplish that. This is kind of the common industry standard, the V-style pinch closing system. This is what you'll often see on most planters from factory. It works in a variety of conditions. There's some conditions I would say is probably not the best option, but that's one of the things that are out there. You can get them with pinch style, with just rubber wheels, spikes, tines, all different kind of variations on these that are out there. Kind of a couple of key things is that you want enough force, enough weight to actually push the trench back close again without creating a compaction layer on top. But you also want to make sure that you close all the air pockets that are underneath it. And you want to start from the bottom up. You always want to start at the bottom of the trench and close it from the bottom up. With these pinch style closing systems, one of the key things to make sure of is that they're centered on the row unit. We like to do what I would refer to as a scratch test. Set the planter down on something hard that you can, piece of wood or something that you can see a mark from the disc openers. Pull forward a little bit and then stop and see where is the disc, where's the center of these closing systems? Are they centered over top of your disc opener trench or your V trench? If they're not, what's causing is you're not going to close the trench from the bottom up because one side's going to be off to the side, the other's going to be on top of the trench. Now you can start to get an issue with your closing system because you're not centered on top of the trench itself. To fix that, take your bolts loose here, realign this. You also have eccentric bushings in here that you can adjust as well to try and move this back over where it's supposed to be. One of the things that you want to make sure of is the distance between these two closing systems. You want to make sure that the gauge wheel is set correctly for the depth that you're running. This one here, for 2.5 inch planting depth, I would say you want to be about 2 inches. This is, or 2.5 inches. This is just under, that's about 1.5 inches between this point and this point in the rubber wheel. That's a little too close for me on a 2 inch gauge, on a 2 inch planting depth. If I was doing 2 inch planting depth, I want to be more like this one here that's set up. It's got an extra spacer on this side. You can see that. If I come in here, this is about 2 inches, maybe about 2.5 inches of depth. Now, I don't like the fact that it's all on one side. I would try to split that, get that equal so you're an equal distance on both sides of those. But that is the proper depth or proper spacing on the two rubber wheels to get them far enough apart that you are closing from the bottom up. If you get them too narrow of a trench, what you're actually starting to do is you're going to close the top off and you leave an air pocket above the seed trench. If you get them too wide, you won't close the top up, but you close the bottom, and then you'll have a chance for the furrow to open back up again as it dries out. So it's important that this is set correctly as far as how wide it is. Otherwise, you're going to run into issues with it not getting close to the bottom of the trench, or it'll close the bottom but not the top up. If you drastically change your depth, there's a good chance you're going to want to change the spacing on these. So for guys that are planting sugar beets at a shallow depth or something along those, where we're going an inch deep, maybe you're planting cotton or something along those lines, take a spacer out and move these closer together to try and compensate for that depth. As you get into deep corn again, you get into deeper conditions, maybe you're going 2.5 inches, you'll want these to be widened out again. Another thing is you can see these have got a stagger on them. These closing systems have 2 holes in the back of this. If you're in the sand, it's probably not a big deal to leave them in the front, leave them equal, offset side by side, so you can pinch that sand together. As you get into clay or some of your harder closing soil structures, an offset actually tends to help. You can get one further than the other, so you can push it one way and then push it back the other way to try and close that trench up from top to bottom. Those are generally pretty good options with it. If you're going to get into a system outside of a rubber wheel or a cast closing system on it, one of the key things to look for that I would say is if you're running spikes or something along those lines, a lot of times I'd recommend pulling a drag chain with it. If you can keep something to help pull the fines back across it, again, that's dependent on soil type and soil structure. Some of those are going to make a big difference as far as how to make that work. So, Joe, we have a question. Does the spacing of your closing wheel change according to your type of closing wheels? It would make some difference depending on whether you're running spikes. If you've got a cast or a rubber, poly twisters, I would probably say almost all of those are going to be about the same. If you're running the big Martin spikes or big spike wheel, those you could probably want to make sure that you've got them clear enough space far enough apart that they're not going to obstruct or damage your seed furrow as far as placement of seed, but they still want to close it well enough. So Dawn Curve Tines, Dawn I know has their own specifications, I believe, as to how close they want them, how tight they want them to be. So some of those I would recommend looking at what they actually specify as far as closing systems as well.
Where exactly were you measuring on the closing system?
So the question is, where was I actually measuring on the closing system? That's actually from the center of the rubber tire to the center of the rubber tire. So if you get down tight and close enough at the very bottom, you can get down here and see from this point to this point, very center of this rubber wheel to very center of this rubber wheel is what I'm trying to measure across it. Good question. All right. If you've got a system in here, we got 2x2 coulters in here, you got fertilizer application, make sure that you can still close the system that is still centered. That scratch test is very important. The further back this closing system gets, the more important it is to make sure that it's centered on top of it.
You mentioned the depth determines how wide. Can you go over that again?
Yep. So the question was the depth that you're planting is a condition of how wide to make this. So I'll cover this one more time, cover it again, and see if we can explain it. As I go deeper with my disc openers, as I plant deeper into the ground, the contact point or the location that these two lines intersect is either going to, as I go deeper, if I don't move these wheels out, that intersection between those two between the two press wheels is going to be either above or below where that seed is actually placed. My idea is that I want this to be set so that the rubber wheels, as they're coming together, that if you draw a line from the force point from these two, basically if you line this place up, where does it intersect, and line this one up, where does it intersect? I want that intersection to be right at the seed or just above the seed. And so if I plant shallower, and I lay these wide, what's going to happen is that I'm going to be below the seed point, and I'm going to keep trying to close a point below the seed and bring it up to the top. That's not going to be as effective as if I bring these together and get that intersection point to be much closer to the depth of the seed that's in the ground. If I go deeper, I've got to go even a little bit wider to try and get that intersection point to match up to the seed in the ground. Great question. You got another one? All right. I think that covers most of the stuff that I was going to cover. So if there's general questions that we haven't come in yet, love to talk through a couple of those. We got one.
Can you go over the amount of pressure on a Keaton? You said 28 pounds.
28 inch pounds, sorry. So the question is, what is the amount of pressure on a Keaton? 20 inch pounds is what I would like of actual force lifting is what I'm wanting for it. So 20 inch pounds of force at the point that the Keaton starts to come off the ground is what I'm looking for, is 20 inch pounds. So, all right. One more thing I will talk about, just as we've talked through emergence. I'm actually going to talk a little bit about a flag kit. We've talked through how well we've done. I want to just pull this out and just pull a couple of things out. You can get a precision planting flag kit for free to help evaluate your emergence score. We sell it as the kit, so you can do a 70 flag kit, which is corn, soybeans, some are corn, cotton, sunflowers, kind of a lower population. You can also get a 140 one, which is what this one is. And then this is the corn kit. These are two things that you can use to evaluate emergence. It comes with all the instructions on what you can, with the process to do the flag kit, kind of a worksheet to go with it, and comes with a seed digger to be able to evaluate the seed, see if there's seed in the ground as well, and evaluate what's going on. Great tool to be able to diagnose how well we're doing. Again, that is a free kit. You can go to our website and order that free kit for free. We will send it to you to help evaluate your planter performance coming this spring. Joel, any more questions that have come in?
Is there a difference between corn and soybean depth when adjusting closing wheel spacing?
So the question is there a difference between corn and soybean depth when adjusting closing systems? Most of the time that I've seen, unless you're drastically planting soybeans at a lot different depth than your corn, most of the time I'd say you're probably good to leave them at one closing spacing. I wouldn't probably change them that much unless I'm really going, if I'm going 2.5 on corn, I'm going to 1 inch on soybeans. That would be the difference that I would say. Most of the time I'm going to plant my soybeans closer to the 2 inch depth, closer to my corn depth. It's probably close enough that I wouldn't go through the effort to try and change the closing wheel.
Is there a specific weight on the closing wheel you're looking for?
Is there a specific weight on the closing wheel I'm looking for? It's a little challenging to judge that number. It's all based on how well am I closing, am I getting rid of the air gap that's behind it? A good way to do this is actually dig across the furrow after you go through the field. Dig across the furrow and create a trench so you can kind of find that V trench and then dig along the furrow until you get to the next seed. So dig across it this way and then dig down the trench and start pull it back as you go to see, is there an air pocket underneath it? And then is there a density layer across the top of it that's actually causing an issue that's creating it's going to create a hindrance to soil, to seed coming up through a hard pan or layer on top of it. There's not a specific number. Ideally, it depends on what your closing system is as to how much pressure you'd like to see on it. The best way, the enough weight is the right answer. I don't have a magic number of what that weight should be.
Can you briefly go over different closing systems, including case and furrow force?
Okay, so we can go over different closing systems, including case and furrow force. We talked through kind of the pinch stock closing system here. The case closing system is a 2-stage closing system as well as the furrow force system. And what we're talking about with those is that if you would draw it out, so here's your closing frame, you got a disc up front here on each side, and then you got a press wheel in the back that's actually firming the soil down. And the way these systems are actually working is that there is a disc up front that is going running alongside each furrow, and they're lifting and trying to shatter and bring that dirt profile back together again to the top of the trench. And then so that's the structure, deconstructing that V trench and bringing the soil back together again. And then the packing wheel on top of it, on the back of it, is trying to firm down the soil profile enough to keep it from drying out and to make sure that we don't have any basically keep it from drying out and make sure it doesn't fall back apart again. But the main closing aspect is from the disc openers at the front, going from the front, from the bottom up. There are some marked differences between furrow force and case. A large part of it comes down to these two discs in the front. These are actually on a case. The disc is straight with a curve concave to it. The furrow force is a concave at the bottom that goes from the bottom all the way to the top of it. So there are some differences in how those are actually function. But they are two styles closing systems. I hope that answers the question. You got another one?
Talking about the different weight on the closing system for your wheel handle position, what's the best way? Have you ever used a spring scale to set those? Or
you can use a spring scale. So you can get an idea of how much pressure that is. You can take a bathroom scale underneath those. Those are pretty static settings, and you can kind of get an idea for what each one is. That's a good reference point for it. Again, it depends on what your soil conditions are, as to how much pressure to set them to. Generally, on a pinch style closing system, I would say more is a little bit better than less. When you get to run into less closing force, especially in no-till conditions, you've got room to put a lot of force to try and close that trench up. It's getting more and more difficult the wetter the conditions get. As you get into drier conditions, your extra force isn't going to cause any issues as far as sealing up. It's really dependent on soil type, but I wouldn't. The idea of using a bathroom scale or something like that to set the tension on those would give you some ideas to make sure that they're all set the same. You can calibrate those based on how tight you make the spring inside those.
So I think we got time for one more question. How much downforce should be on the row cleaners?
Okay, so the question, this will probably be our last question. How much downforce should be on the row cleaners themselves? That's a good question. Let's step over here real quick and take a look at it and the concept of what we're talking through. The idea behind a row cleaner itself is to clean the residue out of the trench. Basically, what you want that row cleaner to do is, if there's residues or big clods or anything like that, you want to move that residue out of the way so that you're not getting it caught in your disc openers, and you've kind of got a little bit of bare dirt on top of it to warm the soil profile up more. How much pressure do you want to put on these row cleaners to keep that in position? It comes down to, can you clean the residue out of the way without creating a divot or creating a trench in front of it? If you get a trench in front of it, now you got a room for water to set in, you got stuff to silt back over top of it, you're going to clean stuff or start to bring residue back over it again. That number is going to depend a lot on what the row cleaner style is. This Martin with a heavy 1360 has got a pretty heavy nose on the front of it. You're going to probably going to apply some lift to this. You get a Yetter 029, the shorter coupled row cleaners that aren't quite as heavy. Those you might want to put more pressure down on those to try and make them. It also depends on how much, if you have a treader wheel here. This is a wide treader wheel. You can get them with 1.25 inches or 1.5 inches treader wheels as well. I would recommend a treader wheel of some kind. If you don't run a treader wheel, now you got to rely completely on the tines themselves to be able to resistance on that. I like to be able to put a treader wheel in here so I can rest on something that doesn't run my closing system too deep, but I can only increase the amount of force on it. So a row cleaner, a air cylinder like this, with clean sweep, Martin's got something similar to it. Yetter's got some things around that with the airbags. There's several different options out there. There's not a magic number of what that is, but what I want it to do is I want it to be able to clean the row out without moving the soil profile with it, get the residue off to the side of it. There is a little bit about the tines that you're running. So a spoke tine like this is really good at sifting through residue and blowing it, moving it out of the way. A curved tine, kind of like the shark's tooth or the razor from Martin's, those are actually really good at cutting residue that's firm on top of the ground and slicing and moving the residue out. They're good in no-till. I would not take a shark tooth into any conventional fields. Those types of blades are really good at moving everything out of the way. And if you can't really sift through residue in a worked field conditions, you're going to move the dirt with it and you'll create a nice big trench with those. This is probably the best option that's got a mixture of soil profiles, a tine approach to it versus a shark tooth approach to it. All right. Any other questions that we've got coming in? All right. I believe that is all I have. I really appreciate you guys taking the time to go through the afternoon or the morning with me. So, and I believe Julia will be able to wrap us up a little bit at the end, but thank you again so much for taking your time and your morning to spend some time. Hopefully these have been good opportunities for you guys to learn and take something back to your farm to learn some more and have a great season this year. So thank you, Julia.
Awesome. Thank you so much, Hans and Joel. That was really great. Very informative and really great to see all the different types of planters that you went through, the case and the deer and the Kinsey. That was really, really helpful. So thank you so much. And thanks to everybody who stuck with us all this time. Just wanted to say real quick before we conclude, we are going to send you a questionnaire to anybody who's still with us to complete. And we'd love it if you fill it out. It'll help us with planning for future webinars. And then also we are making available a replay of this webinar. It will be available on our website later today, and you should get an email about that. So if you have any questions, I know he went through some of this stuff real fast, but you can always go back and rewatch those things if you have any questions about any of the things that he went through. So that will get put up on the No-Till Farmer website shortly. So once again, thank you to Hans and for Joel for leading the discussion about planter setup and maintenance. And Joel, thanks so much for your excellent camera work. And thanks for going through all of those questions, Hans. So thanks so much. Thanks everybody for joining us, and hope you have a great planting season. So thanks so much. Take care, and we'll see you soon.